Hello, you're welcome to this lesson. In this video, you're going to learn about how to differentiate multivariable functions using the chain rule. Okay, so let's look at that. So in this case, you're going to look at case one. Case one. So let's look at what is under case one. So for case one, let's say I have a function z which is equal to f of xy. Okay, f of what? Xy. Okay, so next we have this function here, and then where we have x to be equal to g of t, okay, and then y to be equal to h of what? T. Okay, if you are asked to find dz dt, how is this going to be? So let's look at that. So to do this, I'm going to use the tree diagram. Okay, so let's look at that. So I'm going to have my z here. You know, z is a function of what? X and y, and then x and y are functions of what? T. Okay, so I have my z here. Okay, then since z is a function of x and y, okay, I'm going to, let me clean this. I'm going to bring x and y here to show that what z is a function of what? X and y. And then x is a function of t, as you can see here. And then y is also a function of what? T. So let's do that here. So I have t here, and then I have t here. Okay, so this is what you have now. So to find the derivative of the function, this is what you are going to do. So since z is made up of two variables, okay, we are first of all going to differentiate with respect to what? With respect to what? X, and then we differentiate with respect to what? Y. So let's look at that. So I'm going to have dz dx, okay, because this is a partial derivative. Let me write this again, dx, okay. Then from here, you are going to have dx dt. You know, x has only one variable, so that's going to be dx dt. Okay, and then for y, you're going to differentiate z with respect to what? Y, and it's going to be partial derivative because z has x and y as what? Variables. So you're going to have dz dy. Okay, this is what you have. I'll write this again. And then from here, I'm going to differentiate y with respect to what? T. So that will be dy dt. Okay, so you see the difference for z. Okay, for z with respect to what? X and y, we use partial derivative, and then for x and y with respect to what? T, we use the normal derivative. So at the end, let's look at what you are going to do. So we're going to have dz dt, okay, to be equal to, I'm going to multiply all what we have here and then add to all that we have here. Okay, so let's look at that. So for this reason, I'll bring plus here. Okay, so let's look at that. So I'm going to have dz dx. Okay, and then we're going to multiply by dx dt. Okay, then from here, I'm going to add this to dz dy. Okay, multiplying dy dt. Okay, you can call this symbol as del. Okay, you can call it as what? Del also. So let's continue. So this is the general form of such expressions, and then this is the case one. So I'm going to take an example to help us understand this better. So let's go ahead. So let's say we have a function z, okay, which is equal to x multiplying e to the power xy, okay, where x equals t squared and then y equals t to the power minus 1. Okay, so you have to find dz dt. So what you have to do first is to find the derivative of z with respect to what? X, right? So let's look at that. So first of all, I'm going to differentiate x and then keep e to the power xy. So I'm going to have 1 multiplying e to the power xy. Then from there, I'm going to keep x and then differentiate e to the power xy. That will be e to the power xy, and I'll differentiate this xy here with respect to what? X. That will give us what? Y. So when you simplify this, you're going to have e to the power xy plus xy e to the power what? Xy. Okay, this is what we have. So now let's find the derivative of z with respect to what? Y. So let's look at that. So for this one here, this x here will be kept as a constant. So I'm going to have x and then I'll differentiate e to the power xy with respect to what? Y. So I'm going to have e to the power xy multiplying what? Y, right? So let's look at this. This will be equal to xy. Okay, sorry, we are differentiating with respect to y, so that will be times what? X. Okay, we have xy, right? So when I differentiate with respect to y, that will give us what? X and not y. Let's take note of that. We're going to have times what? X. So simplifying this, I'm going to have x squared multiplying e to the power of xy. So now let's find the x dt. Okay, so I'm going to have the x dt. So you have x to be what? T squared. So the x dt will be what? 2t. And then we are going to find dy dt. Y is equal to t to the power minus 1. So dy dt will be minus t to the power of minus 2, which will be the same as what? Minus 1 over what? T squared. Okay, let's take note of this. Okay, so now what you are going to do is that we are going to apply this general formula that we have here. Okay, so let's look at that. So we're going to have dz dt, okay, to be equal to del z dx, which we got to be, then write this here. We're going to have e to the power xy plus xy multiplying e to the power of xy. Okay, all these times what? Dx dt, which is what? 2t. Okay, so this is what you have then, plus del z del y, which we got to be x squared e to the power of xy, right? Okay, x squared multiplying e to the power xy. Then you're going to multiply this by what? T minus t to the power what? Minus 2, right? So that was minus t to the power minus 2. Okay, this is what you have. So from here, let's try and then simplify this. So I want to write some terms here. I'll write s equals t squared and then y equals t to the power minus 1. Okay, so now let's continue. Okay, so now I'll simplify this expression. Okay, so the z dt, okay, will be equal to, we are going to have 2t, okay, we're going to have 2t multiplying e to the power xy, okay, plus xy multiplying e to the power xy, okay, then minus, because of this negative that we have here, so minus t to the power minus 2, okay, multiplying x squared e to the power xy. So now let's look at this term that we have here, x and then y. So let's find xy, which will be equal to what? T squared times what? T to the power minus 1. And then this will be equal to what? T. So wherever we see xy, we can substitute t there. So we're going to have z dt, okay, to be equal to 2t. Then we have e to the power xy, so that was e to the power t. And then plus xy, so we can bring t. And then e to the power xy, so t again. Then minus, we're going to have t to the power minus 2 multiplying x squared, right? Which will be, we know x to be what? T to the power 2. So we're going to have t to the power 2 squared. So that was t to the power 4. Okay, multiplying e to the power xy, which is what? E to the power t again. Okay, so now let's simplify this. Okay, let's simplify this. I'm going to have I'm going to have 2t, okay, 2t e to the power t plus 2t 2t squared e to the power t. Okay, this is what I'm going to have. And then minus, then I'm going to have t to the power 2 e to the power t. Okay, this is what you have now. So let's look at this. So let's consider these two terms here, right? Let's consider these two terms here. So you have 2t squared e to the power t minus or t squared e to the power t. So you can subtract this from what we have here. So we're going to have 2t e to the power t, okay, and then plus what? T squared e to the power t. So this will be our answer. Thank you very much for watching this video. Please make sure you like and subscribe.